Next up, we have Peter Membrey, who's the Chief Research Officer for ExpressVPN, and he's going to talk about reimagining Lightway, a transition to Rust. Please welcome.
How's that? Okay. Hey everyone, so I'm Pete Membrey from ExpressVPN. I'm not really sure I walked over to here because I don't actually have anything to stare at. And today we're just going to talk a little bit about Lightway and our migration to Rust. And I think this is actually quite an interesting one, mostly because, especially what you might have seen recently with all the talk on, for example, like the Linux kernel and getting Rust into that. There's a big push where people say, when everyone brings up C, the question is, well, just rewrite it in Rust. And that can be annoying. Just rewrite it is one of those, very large simplifications for things that are actually really, really challenging. So for us to have actually taken something that is in production, it's working well, it has and continues to pass multiple security audits, and yet we rewrote everything into Rust. And this is kind of the story of that and some of the details of it. Obviously, I don't have too much time today, but I'm happy to answer any questions or any follow-ups that anyone might have. And let me see if I can make the clicker work. Cool. No clicker. Okay. Yep. There we go. So of course, we'll start off with what Lightway actually is. I need another slide. Good. Cool. So Lightway is ExpressVPN's proprietary protocol. I say proprietary, but it is open source. And it was very much developed to solve the problems that we were seeing creating a large consumer VPN platform at scale. And when we were looking at the space, there really wasn't anything there that would actually do what we wanted. Now again, this is one of the great things about open source. If there isn't something that does what you need, you can potentially create it. So there's lots of options, and we wanted basically to add to that environment and make sure that, for our use case at least, there was something that was more appropriate, was a better fit. So Lightway itself, again, it was engineered by us, so it is opinionated. It does kind of what we want it to do. It's completely open sourced. I will also cover here that the security for Lightway is provided by wolfSSL. It's an open source C library that has multiple certifications, including the latest FIP certifications. And critically, no, we did not roll our own crypto. We used the high quality platform that experts in writing crypto have implemented. Of course, it's open source, as I mentioned. It's also industry leading in that no other VPN provider has taken the time to build something with this sort of depth and complexity and then actually, and certainly not actually release it open source. Have a next slide, please. Oh, wait. Yay, okay. So this is a very brief part. No, I'm not going to read all of these out. But really what I want to kind of highlight here is just how much this has been developed from. So we've released it here, but we've never stopped doing things like security audits, in fact, multiple audits. We deployed post-quantum encryption pretty early on. We also upgraded to DTLS 1.3, which actually was a precursor for the post-quantum. As far as I know, we are pretty much the largest deployment of DTLS 1.3 in the world, mostly because no one else really needs to do what we're kind of doing. But we are still the largest. And of course, last August, I think it was NIST. Oh, no, that was the wrong button. That one, there you go. So yeah, NIST released a new standard, MLChem, which was basically standardizing Kyber. And basically before the end of the year, we had the full ML-Chem hybrid key exchange across our entire platform. So we do like to kind of keep up with the times. And so why Lightway and Rust, though? I mean, again, this thing is clearly already working. It's already doing well. Why do we do this? Well, the reason we changed... Yeah, back when I was here. So the reason we changed was that we wanted to take the benefits that Rust could give, and there are certain benefits that I'll cover briefly, and again, maybe more in the QA. But specifically, moving with the times. When I first designed Lightway in 2020, the requirements were very specific. We had to support low-powered devices. So I'm talking small home routers and the sorts of Android phones you would find in developing markets. At the time, these were not well supported by OpenVPN in the sense that if you put the encryption standards to something that you'd be comfortable with, those devices tended to have trouble pushing the amount of traffic that you would need to watch, even, for example, an HD video stream. The general advice from the industry at the time was to, well, for those use cases, use one of the older protocols, particularly if this is an off-the-shelf router. Your choices, if you don't want to use OpenVPN, tended to be things like L2TP and PPTP. Now, those are not great options. They will let you stream. They will let you do geo unblocking. Security, though, is really not their strong point. So we had to support this. Now, when I was looking into Rust back at the time, there were very nice things about it that I really, really wanted. I wanted that memory safety. I wanted to have a language where I didn't have to worry about slicing my fingers off when I do a simple change. The problem, though, was Rust really wasn't ready yet. In terms of performance, it was still great, but remember, we're trying to get the highest performance we can out of potentially some of the slowest hardware that exists. That's not much fun. In that case, you really need to use something like C because you get all the compiler support for it. And also, actually, when we were trying these builds, there really weren't any, there wasn't much, I should say, good support for running and building Rust for these other embedded platforms. Happily, though, come 2024, that's changed a lot. Rust has an extensive ecosystem now for building on embedded systems, and the performance, in many cases, actually can beat that of C. And there's a few tricks it does to do that, because usually the way it goes is, well, the reason I'm using C is because I can eke every little piece of performance out of this system. And if I use a higher level language, I will lose that ability. In general, that would seem to be true. But what we found with Rust was that when using something like Tokyo, we could actually beat the performance that we could in that on a single core versus an app powered by libuv on a single core. And I can go into some of the high-level reasons why that is. So why we keep up the times? I mean, let's be honest. Like, okay, Rust is a cool, interesting language. Everybody wants to be doing something cool, new, and interesting. But it's not that we made a mistake implementing in C and now we're rewriting it. It is C was the correct language at the time because the tool which would have been better wasn't yet ready. That tool is now ready, and so it was time for us to look at doing this migration because the benefits that Rust could give us, which we'll now cover, were just too good to leave on the table. The main one, security. One of the biggest attack surface you're likely to find in any sort of networking app, particularly when your focus is security and privacy, are things like buffer overflows and stuff like that. Now, Microsoft released a paper. I keep saying it's about 6 years ago, but I've probably been saying that for a couple of years, so I should probably go check when that actually came out. But they actually state that 78% of the massive security bugs that they deal with stem from memory-related issues, bad memory handling, buffer overflows, all that sort of thing. Now, the nice thing if you're using Rust, particularly using safe Rust, and assuming you're not deliberately going out of your way to shoot yourself in the foot, this whole class of problems does not exist here. Now, this is a really key thing. It's not that it is harder to make a terrible mistake. It's not that it's easier to protect yourself. It's that a whole class of attacks cannot happen. This is really cool for us because obviously we want software that's safe and secure. It does drive security auditors kind of nuts though, because the go-to thing is attack the memory. And when you can't attack the memory, it's a lot harder to figure out what you can actually play with. So security was the big thing here, one of our strongest reasons for adopting Rust. The other is performance. If you're trying to do things that are secure and you want to get the best performance out, particularly on networking, with people now having 1 gig or 10 gig internet connections, I actually got an upgraded connection just a few weeks ago in Hong Kong. So my internet connection is actually rated at 50 gig. Now, I'm probably in fact I am actually the only one insane enough to have that in Hong Kong so far. But that gives you an idea of where this is going. And the reason why they're installing this, because I just want it because it's 50 gig, you can't turn that down. But the business reason why they've done this is because they're seeing a massive uptick in people doing virtual reality, augmented reality, and all this stuff means moving lots of data quickly. So they're installing this network and they're making idiots like me pay large amounts of money to have these things installed so that it can pre-fund and pre-set up the rest of the network. So most people aren't going to be seeing these things yet. But with 1 gig connections now being the norm in most places, being able to do this, the performance stuff is important. That often means now, though, that a single core is not enough to saturate your network. This is really new. Like, in the old days, the CPU would be sitting around for ages waiting for the network to catch up with it. Now that's not the case. Now, Lightway in its C form is powered by libuv, which is extremely fast, it's extremely efficient. Good at multi-core, though, particularly when you're dealing with like network streams, that's not its thing. This is a bit like the way Ruby on Rails used to be deployed, where if you need more than one, you deploy more than one, and then you just group them together. And then you can bypass a whole lot of issues like multi-threading. And doing multi-threading in C and doing it safely without making mistakes, far from easy, far from trivial. Rust, however, again, tying in the performance with the security, guarantees that you won't get undefined behavior across threads. That makes writing the apps more fiddly, but the compiler will stop you doing silly stuff. And again, you can work around that to some extent to make it do silly stuff, but you're not going to footgun yourself like you could so easily in C, where a change in one thread 25 minutes later causes another one to crash. It's also easy for extension. The original Lightway was written in C. Spoiler alert, no one likes writing in C. It's not fun. Even the people that like C don't like the tool chains. Anyone who's had to deal with CMake or try and get that to work with modern libraries, it's deeply unpleasant. But everybody right now wants to do Rust. So hopefully this will help make it easier for people to get involved and be more interested in being involved. But it's much nicer working with an extension in Rust where you can use the interfaces and the traits, than it would be to try and get this to work in C. So again, it kind of opens that up as well for us. So just quickly, the breakdowns. If you do an implementation like this properly, the security benefits you get from it are basically unprecedented. In almost every other language, I should say low-level language, where you're actually running as close to hardware as you can because you need that performance, there are very, very sharp edges. And many, many people have been cut on them, myself included. What Rust does really is removes those sharp edges. Does that mean you don't have to think about security or care about this anymore? No, of course not. And we are still very much care about security, but it's nice to know that the compiler's got your back and that the whole ecosystem is designed so that you won't accidentally shoot your leg off. Better performance, again, we're seeing with, for example, with Tokyo, if you turn on the multi-threading, you get access to all the cores in the box. Makes a huge difference. And if you wrote the code nicely to start with, you almost get this for free. I say almost because sometimes you have some shared state. That needs to be carefully managed. But generally speaking, you can get a lot. huge bang for the buck with this, without the dangerous nature of trying to do it manually. It's also more efficient. We've seen when these scenes get compiled down, particularly with things like Tokyo, where it effectively compiles the state machine, we've actually seen better performance, less hits to code, less hits to memory. Is it going to be, is it like twice as performant as C and efficient? No, clearly not. But when you're building this stuff, a few percentage points really matters. It's also more efficient from just writing code and testing code. The compiler really helps you. I don't know if you've seen Rust error messages, but they are lovely. They come with man pages and examples where you might find this, what you probably should have done instead. It's so much nicer than dealing with C, or particularly like C++ templates and things. And again, it's easier to extend. The crate ecosystem's nice. The general community is nice. We can do more, and we can do it faster. And because we've got because we can rely on those things, there's less bloat in our code as well. So those are the main reasons we did it. We want to be faster. We want more security. This gives us both, and the language kind of has our back. But we are really focused on trust and transparency. It's what we do. So Lightway's actually been so Lightway Rust, I should say, should be clear on that, was put through 2 audits before we released it. One by Cure53 out of Germany and one by Praetorian out of the US. This is what we got from Cure53. Very limited number of findings. Can be termed as a positive sign for the security of the ExpressVPN Lightway protocol. If you've ever worked with Cure53, you will know this is very, very high praise. The amount of conversations we've had on things that were, let's be honest, irrelevant, but we're going in there anyway, to have that sort of feedback says a lot. Now, a lot of this is because when they or any other author goes hunting for these bugs, again, it's memory where you start looking. That's where the gold is. That can't happen here. So their entire class of easy attacks doesn't exist. For Praetorian, they actually wrote us, a bit more. Following effective controls are particularly beneficial and warrant special recognition. We were very careful using Rust unsafe blocks. They're in very specific areas. The Lightway core itself, the implementation of the Lightway protocol, is marked that unsafe code is forbidden. However, because we've also created libraries to support WolfSSL, which is a C library, you're going to get some unsafe in there. But it's very well documented. It's very clear where everything is, and great care has been taken with it. We use the strongest cryptographic primitives that currently exist, and we have a very responsive security team. They're not wrong. We have a great security team. But it was a very active, involved audit, and again, overall, there was very little that was found, and a lot of that is due to the language itself. The nice thing is when you give this to an auditor and say, I want to make sure there's no undefined behavior in here, by the way, it's set to forbid unsafe code, they can effectively just compile it and go, you're good, because the compiler will ensure that this is the case. And that is a huge win. It's open sourced. We've open sourced the Lightway, the Rust version. What's better and more interesting than the last version was we open sourced Lightway core, which is the library that implements all of Lightway. And then we had a simple application that would demo its use. The idea was you could embed this into any app you wanted and have a play with it. And nobody did. Fine, nobody wants to work with C. We get it. This time around, though, having learned from that lesson, we have the Rust crate, which is the Lightway core implementation. However, we also have a server and client that's fully usable. You could use this to build your own VPN server implementation and play with it out of the box. So that's fully available now. And again, we've already accepted PRs. Ironically, in the WolfSSL bit, people have found that through our crate, and now they've gone to update that. But we are starting to get a few pull requests in. And yeah, we're hoping to, like, kind of one of our goals is to end up with, apt install Lightway or something like that. So hopefully we'll start seeing this get packaged. And again, we're willing to put funding and support behind getting out there. So we're looking to build a much more vibrant community than what happened with our last attempt at that. So how does it come together? This is one of my better platforms, Aircove. It's a router. It's not open source. Not going to do a sales pitch. But the key things I want to point out is it's running the new Lightway version, and its speed went up 2x, which for us was absolutely huge. The biggest challenge we had with the router, with the embedded hardware, was that it just couldn't push traffic. But switching from the C to Rust gave this benefit, and this hasn't really been super optimized yet. This is our standard Rust build compiled, maybe a few minor tweaks for the architecture it runs on, but nothing, like no one's sat there and done detailed analysis of CPU use and stuff like that. So I expect this will get better. And we also have another security audit for that. So we're quite into our security audits. So what's next? Well, we're hitting on the road, part of the reason why we're here. Hey, I'm actually pretty good for time for once. So we're in FOSSASIA, obviously. We're also going to be at the Rust Asia in a few weeks. So if anyone, that's in Hong Kong, but if anyone's interested in going there or is going there, we'll be doing some more talks on this, and all of our team will be milling around. So if you are interested in Rust in general, there's a lot of people there who'll be happy to talk to you. We have more improvements and enhancements planned. So part of the reason of putting Lightway into Rust is because doing changes in C is unpleasant. With C, you have to make decisions like, which hash map library do I use? And when you go look for a hash map library, there's about 50 of them. And you don't really know which is the one you should be using. And it's just, again, it's painful. With Rust, we can do stuff far more quickly. People can test stuff more quickly. People can adapt stuff more quickly. Again, it's just a benefit of the language and the fact that right now there is admittedly some hype behind Rust. There's a lot of excitement behind it, and in my opinion, for good reason, and we're putting it to good use. So yeah, I mean, that's really going to help with these enhancements and improvements. Plus, there's lots of really high-quality crates that we can now effectively pull in. Because people are excited about Rust and doing stuff over there, we can kind of borrow it over here and get the benefits from that as well. So we can much more easily leverage open source projects and collaborate with those different those developers as well. And last, we're still working on challenging the industry. As far as I know, this is the only protocol that's written in Rust. Probably not too surprising, given that everybody else is kind of using off-the-shelf protocols, and we're the only one that wrote our own. But we are trying to push the idea of that there are better and safer ways. The reason we've released Lightway is partly because, well, one, for the trust, two, for giving back to the community, from which we've gained so much, but also to give another option. Now, like I said, it's opinionated because it's basically what I felt, having been responsible for running a very large consumer VPN platform for over half a decade. I need to say I hit some pain points. So Lightway was created to solve my pain points, and I'm not that special. Other people are going to other people have these pain points. And so for that reason, I think Lightway is also a useful tool to have in your pocket. Even if you use other protocols, there may very well be cases where this is a useful thing for you. Two areas, because I think I still have a minute or so to go, that Lightway is kind of unique on. It is extremely fast for what it does, but we do support natively both TCP and UDP. That's quite rare. And the TCP is almost as fast as the UDP, which is also very rare. The other thing is Wolf SSL itself is fully FIPS certified. It would be possible with some effort to also get Lightway FIPS certified. So if someone wanted this for more, to use and say, oh yeah, I like government use cases, Lightway is well staged for it. It's also post-quantum secure in the sense that we've taken the best post-quantum tech that's currently available and we've applied it. So we're following all the NIST standards. We use the highest level of ML-Chem for both UDP and for TCP. We actually funded FOSSASIA through the open source side of things to add enhancements to DTLS so that it could support the bigger key sizes. Otherwise, you get fragmentation. So even with that side, we're still putting back out there. We're still making this stronger for other people. And that's it with, I think, 60 seconds to go.
I'm going to experiment with standing on this side of the room so I'm not in the way of the microphone receiver. Maybe that works better. Awesome. I have many questions, but audience first. Questions, anyone? Go ahead.
Any guess on the developer productivity improvement roughly?
Probably the closest I can put that is, so for me personally, if I needed performance, I wrote in C. If I needed to just do something, probably Python. Now I just reach for Rust for both. Rust has actually been very unique for me in the sense that I can write firmware for, say, a crypto USB stick, and it feels a good fit. But I can also write a web service in Rust, and it feels a good fit. And I've never seen that for any other language. We haven't touched on it here, but we do have, obviously, in our apps themselves, they call APIs, they do authentication, stuff like that. The library that's built into the apps is written in Rust, and that's has all the cross-platform bindings. The web service it talks to is also written in Rust, and the same people that are writing the client SDK are writing the web services, and they're absolutely loving it. To the point where all new web services that this team will create will be in Rust. So Go had effectively been our standard, but all new stuff, at least for this part of the team, will now be in Rust. So far, the feedback has been good, especially from people who are new to programming. They love it. And people who are more experienced are really enjoying the more modern tool chain and stuff that's available.
One of my questions is related. I forgot before starting Q&A. Sachin, are you in the room? Sachin Bakar? Could you please speak to these gentlemen here about your slides? Thank you. Right. Next question. Anyone?
Yeah, thanks for your talk. Was it difficult? So in my company, it can sometimes be difficult to convince the quote-unquote business of a big technical migration like this. Was it difficult to communicate that you wanted to do this, that this was like a necessary thing, or was it not hard to convince your management? Or
so I'm kind of in the lucky, unique position that we basically stand for trust and privacy. So we're always looking for new ways to do that better. And when I could say, look, if we just use this language, we will get all those benefits. Oh, by the way, we can solve the multi-core problem safely, and we can solve these other issues safely. I'd say it was a relatively easy sell as far as big, scary projects go. It was much more to do with what we could do next. So we were already hitting issues with the C version where, it was a single core app. And on a server where we have 100 cores, we just run 50 of them. And that works really well. The problem is now we're seeing individual users that can really push the limits of a single instance on a single core. There isn't really a good way to fix that. You either go multi-core or you kind of go home. And doing multi-core in C is just not something I wanted to do. And it was just too dangerous. So combined with we want to do these bigger, better, amazing things, alongside with it's going to be really, really scary if we do it this way. It's probably actually going to take longer to do this right and then get it audited than it would be to move to this new language, which has all these other benefits as well. I think what's unique is we've done this, and I don't think many people have actually managed to do a whole C to Rust switch for exactly the reason you're mentioning. It's really hard to convince people of the value prop for it. But I think we're also the ones that have kind of done this because it's necessary for the work we do. We've got these two big security audits. They're publicly available, by the way, and they go through in exquisite detail of everything that the auditors tried to do to break it. That report is actually quite useful for this sort of thing, where you can say, look, this class of attacks that keeps most security people up at night, they don't get to play here. Okay, you're going to have other problems to worry about, but that whole class is gone.
That was part of the logic for Java 30 years ago,
Yeah.
which was you simply can't express pointer arithmetic bugs or
Yeah.
several others, and array overflows are automatically checked
Yep.
in the runtime. One thing, if you politely ignore all of the other things Java got wrong, one thing that seems a bit hard to escape is garbage collection. How does Rust, do you explicitly dispose? Do you have the option to explicitly dispose? How is that handled?
So Rust doesn't have any garbage collection.
Right.
It's all done through memory management.
That solves the problem. Okay.
But the sneak is actually interesting. So I found that if you're into hardware, so the way Rust works is when something grabs some memory, it owns that memory, and only it can change it. There's a few bits of sleight of hand you can do for optimization and stuff like that. But if this thread or this variable owns it, and you want something else to change it, you have to then transfer that ownership to that new thing.
Right.
And so no two things can change it at the same time, which removes a whole class of problems. If you're coming from a hardware background, the idea that only one thing can touch it at once just makes perfect sense. If you're coming to it from like dynamic software languages, this is deeply disturbing. People who've worked on it, like some have come back with, it's just really weird and really new. But for most people that I've worked with, where they're doing really stuff that you would normally do in, say, a Python script or something like that, it doesn't really get in your way. You don't really deal with it at all. It's only when you start saying, cool, I want to do multi-threads now, or I want to do something a bit more special, that you start arguing with the borrow checker a bit. Yep. But the nice thing is all these things are, at least for the undefined behavior stuff, the ownership's all checked at compile time. So there's no runtime penalty for that aspect of it.
Neat. So that's stuff that Java missed completely. Instead, it was like, how does C do it? And then let's build in the synchronous blocks. So,
yeah.
We are, yes, my failure to invite the gentleman means it's taking longer. I'll take one over here.
Thank you very much for your talk. And as I am a Rust developer myself, I find fascinating that ExpressVPN you decide to use Rust in the first place, because as for myself, I have to integrate C++ application to Rust, and I have the same feeling as you, security thing and whatnot. And my question is, and you mentioned that Tokyo have some kind of a single, I'm not sure, a single thread or multi-thread, a synchronous thing. My question is, do you think that Tokyo can be improved in not like some kind of message communication between threads? Because as far as I'm using right now, they have only kind of two way, broadcast or MPSC. And should it have more some kind of more schema in order to communicate between threads, something like that?
Okay, so you're thinking more of like the Elixir Erlang message passing models?
Yeah, something like that. Between threads, especially when it comes to Tokyo.
Okay, so I mean, so I've always been one of those people that tries to pick the right tool for the job. Before I was at Express, I worked for a market maker, and I designed a market gateway that was responsible for transferring market data from co-located data centers to trading applications. And the level and speed of data you had to handle meant you weren't doing this in a single core. So I actually wrote that in Erlang, and the thing was amazing. It was so simple to work with. It was effectively indestructible. There was nothing we were able to do to even break it. Really nice piece of kit. There are a few libraries in Rust that actually try to create that. Some actually are based on OTP, which is the platform from Erlang. The challenge that the people in Tokyo will have is, one, we need more people with that use case. So right now we see it mostly being used, I think, for like underlying network processing and website stuff like web services, things like that, where almost all of the requests can be handled in one thread, in which case you don't need to pay the penalty for doing cross-thread communication. But yeah, I would like there to be more. But yeah, we're just going to have to get more people with the use case to come and ask for it, or demonstrate where it'd be useful.
Thank you, Peter. It's a fascinating application of I think, a really useful approach.